Okay, when last we met to talk about this particular note sheet, we are on 1.2 part 1, an introduction to Mr. Unit Circle. We started talking about the definition of the unit circle. And in discussing the warm-up over with you folks, we have come to understand that when we say unit, we mean one. And when we say unit circle, throughout the course of the warm-up, we've come to understand that specifically as a circle with a center at the origin and with a radius of 1. So it's a very special type of circle. So today's the day where we put our understanding of the unit circle, degrees and radians, together with our understanding of the 45, 45, 90 and 30, 60, 90 triangles. Our overarching goal for today, by far, is to take a look at, for instance, the sine of 30 degrees, or the cosine of 30 degrees, or the sine of 45 degrees, or the cosine of 45 degrees, any of these problems, and evaluate them without touching a calculator. That's overall what we're going to go ahead and take care of today. So first, I guess we can make it official. We do have a definition for our unit circle. It is a circle with a center at the origin and a radius equal to 1. So what we have over here is our unit circle. In other words, my center is at 0, 0, and the radius is 1. Now, we know that in trigonometry, we can define an angle, theta, by amount of rotation, and an amount of rotation. So let's take a second and make it official. What I've essentially done here is I've constructed an angle, theta, and I've rotated it about halfway through quadrant 1 to go ahead and draw that. The stopping point of this ray is indeed a point. What I've done here is I've drawn point P. This radius stops rotating at point P right there, and that point does have a coordinate associated with it. But let me not get too far ahead of myself. I wanted to talk about what that point P should be. Essentially, to get to any point, you have to travel across a certain distance and up a certain distance to get to it. It's really common that if we call a point x comma y, essentially that coordinate there tells us how to get to that point. So for instance, if I call my point P x comma y, that tells me that I've traveled across a distance of x, so that segment there is x, but at the same time I've gone up a distance of y in my coordinate plane. And you see, in tracing out the path to get to this point, I've drawn a right triangle. I went over x and I went up y, and I landed at point P x y. So this is essentially a right triangle, and we know that we've been working pretty steadily with right triangles lately with respect to SOHCAHTOA. So I wanted you to develop new definitions for sine and cosine today within the context of your unit circle. And what you need to come to understand today is that, you know, we have in the past said, hey, sine of theta, that's just our opposite over our hypotenuse. But if we look at where theta is on our circle, theta being right here, the opposite side is actually your y value, while your hypotenuse is 1. So the opposite side is y, while the hypotenuse is 1. If I just divide this out, y divided by 1, that's just y. That's not too bad. So what I'm trying to tell you is that you could find the sine of theta just by looking at the y coordinate. Now let's take a look at cosine. So cosine of an angle theta, you might recall, is equal to the ratio of your adjacent side over your hypotenuse. And my adjacent side here is x. If I look at theta, it's the side right next to theta, that's x. And the hypotenuse is still just 1 right there. So if the adjacent side is x and the hypotenuse is 1, if I do x divided by 1, that's just x. So if I want to find the cosine of an angle, I can just identify the x coordinate at that angle. And we spent all day yesterday talking about the different ordered pairs around the whole circle. So you'll be using those ordered pairs. It'll definitely be handy to have a unit circle in front of you as you work through today's lesson. Okay, so in example 1, what I'm going to do is use this idea of my SOHCAHTOA to sort of support why I can find the sine of 30 by just looking at the coordinates on the unit circle. So I have the sine of 30 degrees there. First thing I would do, if I look at part A and C, I notice that I'm asked to look at a 30-degree angle. So I'd probably start by drawing a 30-degree angle in there. Again, the radius is 1. Theta was 30 degrees. And yesterday we talked about how, you know, there's a coordinate associated with that point right there. We traveled across a distance of the square root of 3 over 2 and up a half. So if I want to think about the sine of 30 degrees, we talked about how that was equal to the opposite over the hypotenuse for a 30-degree angle. And today on the unit circle, we're coming to understand that the sine of 30 degrees, opposite 30 degrees is a half, while the hypotenuse and the radius always line up to be 1. 1/2 divided by 1 is just a half. So it really was just the y coordinate for 30 degrees. Cosine, that there is adjacent over hypotenuse. So if I look at my 30-degree angle and look adjacent to it, what I actually see adjacent to theta is the square root of 3 over 2. The hypotenuse is still 1. So if I put those in a ratio together, I have the square root of 3 over 2 divided by 1. That is just the square root of 3 over 2. Essentially, it was just your x coordinate. You could do this really for any angle as you work your way around the circle. Now, for instance, we could do it again with 45 degrees. So you draw in your 45-degree angle. You know that this radius is 1 because it's on the unit circle. And yesterday, the path we followed to get to that point P was the square root of 2 over 2, comma, square root of 2 over 2. So we traveled the square root of 2 over 2 over, and we went up the square root of 2 over 2. And we found that by doing our rules for special right triangles. So the sine of 45 degrees is, again, our opposite over hypotenuse. And our hypotenuse is always 1. And the opposite side is going to be just the square root of 2 over 2. So what you see is that we do indeed end up getting, when we do opposite over hypotenuse, we get the square root of 2 over 2 divided by 1. Essentially, we got the square root of 2 over 2, or the y coordinate. The cosine is going to be your adjacent over your hypotenuse. Adjacent over hypotenuse in this case is going to be the square root of 2 over 2 divided by 1 again. Square root of 2 over 2 divided by 1 is just the square root of 2 over 2. So it's in that regard that I probably just could have looked at the x coordinate to begin with to evaluate the cosine of 45. So, in a nutshell, here's what I'm trying to get you to understand today. Ultimately, eyes on the prize, the big idea of today's lesson, oops, isn't a green dot. Sorry. It's this. If you want to find the sine value of an angle, you just look for the y coordinate on your unit circle. Oops, the word coordinate's already there. You look for the y coordinate. And your cosine value of an angle is just your x coordinate. So if you're able to get that out of today's lesson, that is awesome. So Sine of 60 degrees. Let's try it this way. If you take a look at part A, I'm asked to find the sine of 60 degrees. So go ahead, look at your unit circle. Look at it. Look at it. 60 degrees is what you're looking for. Do you see it? The coordinate we found at 60 degrees is going to be 1/2, comma, square root of 3 over 2. And what I'm trying to say in today's lesson is that the sine of 60 degrees is just the y-coordinate at 60 degrees. The y-coordinate, square root of 3 over 2. Cosine is your x-coordinate, so that is 1/2. And this is how you're going to do the worksheet that your wonderful substitute is going to give you in just a moment. Sine of 90 degrees. The sine of 90 degrees, just to let you know, can be found by looking at the y-coordinate at 90 degrees. The y-coordinate at 90 degrees was over 0 and up 1. So the sine value for 90 degrees is 1. Our calculator will attest to this, you know. If you hit sine 90, poof, 1 is indeed what you get. So your calculator will support your response ultimately. Cosine of 90 degrees, that is your x-coordinate at 90 degrees. Your x-coordinate at 90 degrees is 0. So the answer here is 0. Okay, so this is the way I want you to conduct the 1.2 Part 1 worksheet. You're going to be asked to find the sine, cosine of different angles. You're going to look at your unit circle, maybe jot down the coordinate, and then if you're asked for the sine value, you have to find the y value at that coordinate. And if you're asked for cosine, you have to identify the x coordinate there. You could also check them with a calculator. Make sure that you're getting what you're supposed to get. All right, good luck on that assignment.